Literally that simple. When you're looking at the telecommunications, I don't think we did this one on Friday. They give you this model. It gives you some formula. And it's the number, T is the number of years since 1989. So 1 year after 1989 would be 1990 and so on. So year 0 in this case is 1989. Which basically tells you that in 1989, how many billions of dollars were spent on long-distance phone calls? At year 0, exactly, 51. 51 billion was spent. If you think about it, year 0, okay? Yes, back in the day, you had a thing in your house called a telephone. It was connected to the wall. I know. Sometimes those phones had things called cords, and sometimes they had things that were called antennas because they were wireless. So you could walk around on a wireless phone with an antenna. I know. It's crazy. Sometimes you can hear your neighbors' conversations on your phones because of the way that things work. They weren't all that great. But back in the day, it was cool. So you also had to have what's called long-distance service. You could have local with one phone company and long distance with another, all with the same phone number. It was weird. I know. Nowadays you're like, who uses a phone? Anyway, all this is telling you to do is to go to your calculator and throw it in. It was what? Points. In the 80s? It was alright.
It was so much cooler now. Music was better.
80s music sucked.
No, it didn't.
80s music is awful.
No.
A lot of 80s music.
Okay,
a lot
not
of
like
80s
80s,
music.
but just like, not just specifically 80s. Just like older music.
When you go into this, obviously right off the bat, it may or may not show on your graph. But in this case here, if you read the problem, does it matter to you, anything about the graph? If you read the question, it's asking you, what year did the amount of money spent reach 60 billion? Which means, do you even need to bother looking at the graph? Look at your table. You're looking for the table. You're looking for something to equal 60 billion. So you're looking in your table then, the second table, you're looking for, my table set's off. I'm looking to where it crosses and turns into about 60 in the Y value. Remember, your time in years, your X value in this case is your years. Year 0 obviously is at 51 billion. Year 1, 1990, and so on. So here you have 89, 90, 91, and so on. In what year did it cross over into 60 billion? And roughly here, between 92 and 93. Year 93, in 1993, it was over 60 billion. That's all you're doing. That's it. No math needed. Buttons. If these things were just touchscreen, you'd probably be better at it. You know phones used to have buttons, right?
On my home phone.
All right. What else you want to look at then? Oops, we don't need this one. Like I said, most of these things were all just straight press buttons in a calculator. I think there was one that I got to you guys the last page. I forgot to put the questions on it, right? You guys figured that out. All you could be able to do is just set up the problem. I just didn't put a question on it. Yeah, for these two, I forgot to add those in. So. Any other questions on the word stuff? Anything else you want to look at? Yes, ma'am. 80. Volcanic cone Pupai. Is that how you say it?
Why?
More of a what?
Not
Right, I have no idea what we're doing.
Ooh.
So you use
Ooh. Poo-poo.
That's right. I got a little.
You okay?
Yeah.
All right. Whatever. But it, not like whatever to you, but whatever the problem.
I was like, jeez.
If not the nicest person you guys know. It was formed in 59, massive lava fountain erupted, blah, 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 shooting lava hundreds of feet into the air. When the eruption was most intense, the height h, in feet, the lava in t seconds after being ejected from the ground could be modeled by blah. Okay? What was the initial velocity of the lava? What's the initial velocity? 350. 350. Yeah, feet per second. This is feet per second in this case. What's the lava's maximum height above the ground? Well, remember, what goes up must come down. What lies at every maximum? The axis of symmetry.
Oh.
In this case here, it's really fast just to do your axis of symmetry because this is in standard form. Remember, axis of symmetry is opposite of b over 2a. So in this case, it would be negative 350 over 2 times negative 16. That will give me my x coordinate for my axis of symmetry. When I do that, I could go to my calculator and try to graph it, hit the max min button, and hit the calculate maximum, but I'd have to find the value in the quadratic, and that sometimes is a pain in the butt. If you're given a standard form equation, it's always faster to do it by hand. So we have, we don't need to do log-based stuff. Alpha y equals fraction bar, negative 350 over negative 32. Do you know how to change that back to a decimal?
So there's a
Math, enter, I believe.
No.
Oh, sorry, you have to go down one, yeah. Math to decimal. So there's your maximum height. So about 11 feet up in the air. Right. What do I do with that value then? I substitute that back in to figure, that's the x, I'm sorry, that's not the height value, that's the x value far over. We substitute that value back into the equation to figure out the height then. The equation was negative 16. So let me show you how you use your answer button. You guys have used the answer button yet in the calculator? All right, let me show you how this works. So we know it's going to be negative 16 times something squared. Well, instead of retyping in this decimal, just hit second, answer. Close the parenthesis, square it, and then add to it 350 times your answer. There's your maximum height then. So the maximum height is at 1,914 feet and change. That's pretty high. 19, bless you. Is that the ash or is that the lava?
lava.
Really? Lava went that high up? That's crazy.
Yeah, one for lava is maximum height.
Wow. That's huge. Wow. I wonder if that's true. If we only could Google it.
Maybe you just think of the
I'll
power.
look it up right now.
Or is it in inches? I don't know. Whatever. It could be. I don't know. I wasn't there. Does that make sense?
Yep.
And then I think in this case here it says for how long was it in the air? You want to find out, well, if we know that our time value, we already figured out this to be this was 10.9375. We figured that out to be 10.9375 for the x value. Now, using our idea of what actually happens, oops, it's a bad graph, sorry. What this is doing, lava went up, lava came down. It started at 0, and it worked its way out. If it started at 0 and at 10.9375 seconds later, it was at its maximum, how long would it be until it got to its ending point? What would you do to this number? Double it. That's the easiest way to do it. If you wanted to factor it, I don't want to factor negative 16t squared plus 350t. That would be a pain, because it's what times what equals 0, bless you, that you add together to get 350. Oh. Ah,
You got somebody gonna leave it?
somebody have to leave?
Hold on, hold on.
Oh.
Hey, Donna, who are you looking for?
I'm leaving. Come on.
I don't know if it's me or not.
That's not
All right. Huh? What you could do is you could use never, ever, ever, never, never, ever, never, 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 ever, never, ever use ever. Factor modeling questions. Don't. You'll kick yourself in the head. Also, try not to use completing the square with those either, because it's a pain. Modeling questions, if you ever had to find zeros, easiest thing to do is use quadratic formula. It's the easiest way. Okay? What's up? Did it work though? Very exciting. Do you guys want to save these to have them so you can keep working off through those? I mean, I know we've done them, and I'm not worried about it. But it's whether or not. I mean, all right. So let's do this. I'm going to skip over 5-7 for now. That way, it'll give us a little bit extra time to work on 5-8, which is great because that'll let us get a little more time on a couple extra word problems thrown in as well. Yes, sir.
It did reach about 1900.
Really? That's crazy. Hey, this problem was real. It wasn't made up. It wasn't fooey balooey.
At 7:25 p.m. local time on November 21st, the fountain went from 210 meters tall to a few gas bubbles in less than 47% of the fountain were extraordinarily high, reaching nearly 580 meters and 1,900 feet among the highest ever recorded.
Wow, that's nuts. 1,900 feet, guys. You know how 1,900 feet is about, I think that's taller than the Sears Tower. I don't think the Sears Tower is more than 1,400 feet. Google that. You got the internet.
14. It's actually, it changed the name.
That's nuts. Bless you.
It is 1,450 feet tall
And
to
then
the
it's
top of the building. It's 1,729.
Wow.
So
So this lava could go up and over the Sears Tower.
Yeah.
That's awesome.
It's actually like the Willis Tower.
Yeah,
It's the Sears Tower. It will always be the Sears Tower.
Yeah, it's the Sears Tower.
It's always going to be.
But I looked up, but I had to look at the Willis Tower, so it would know what I was talking about.
If you Google Sears Tower, it would done the same thing.
I'm sorry,
The internet is somewhat smart. Ish. Ish. So let's talk about this whole modeling thing. So what we can do with the quadratic stuff is we can do a couple of different things. We can actually create our own equations if we're given vertex and points. We can create our own equations if we're given just 3 points. Things like that. And it's actually pretty easy to work with. What we've done in the past, like last year, actually past 2 years since we had all those park tests, we've actually, in that park test, which you guys don't have to worry about, we're not doing it anymore, is that there was this
We're
whole,
not?
no,
Thank goodness.
I know. What we used to have to do was a lot of what's called modeling. And we would always take out all the modeling stuff of all of our chapter sections, and we just put it all in one giant modeling unit towards the end. The benefit of doing that was so that students saw all the modeling stuff right before the park test. Well, we all know how the park test went. And we all know how the test scores worked out. So what I decided to do is just kind of blend it all back in within the regular realms of the units. So why not talk about how do you write equations of quadratics when you're in the quadratics? Why wait till April? Make it no sense, so. That's my Italian. Let's write the quadratic form. Write a quadratic function in vertex form. What we're going to do is we're going to need to remember vertex form, intercept form, and standard form. Those 3 forms. Now, remember, Standard form was your ax squared plus bx plus c. Vertex form, sorry, y equals, is y equals a x minus h quantity squared plus k, where h and k are your vertex. And then the last one's going to be the intercept form, where it's a x minus p x minus q, where p and q are zeros. Okay. Those three forms are pretty easy to work with to write out equations. The first, obviously, with all of these, well, for vertex form, if you have a vertex and some other point, you can write out the equation. But you need to know one, you have to have one of each. So in this case here, we have a vertex at 2, -3, and I have a point at 4 and 1. If I'm looking at this vertex form, there are 1 little, 2 little, 3 little variables, 4 little, 5 variables. There are 5 variables. How many of them do you know? Four. What do you think you're going to solve for then? One of them. Which one don't you know? A. It's a matter of substituting in, solve for A, and rewrite the equation. Okay. So we know in this format here, we have our vertex at 2, -3. The point is 4 and 1. So that means that 1 has to equal A 4 minus 2 quantity squared minus 3. All I did was substitute in. All I'm doing is substituting directly in. What's 4 minus 2? What's 2 squared? 4. So we get 1 equals 4a minus 3. Two-step equation, what do you do? Add 3, divide by 4, and what do you get?
1.
A is 1. Which means when I write out the equation that has that vertex and that point contained in it, it would be this. Y equals x minus 2 quantity squared minus 3. Do I need to put the 1 in front of that? No. If it was -1, I would write -1. But since it's just a 1, I don't have to have it. And now I'm done. There's my vertex form. It is. These problems today are quite literally, for the first 2 formats, it's going to be 5 variables. You know 4 of them. Solve for A. And then just rewrite the equation. Be careful though, when you're using your calculators, don't forget that you have a negative and you're squaring it. Make sure you have parentheses around it because you will screw that up. Okay? Not terrible? Try another one. Oh, that we just did that. No, didn't do that. No. This one, yeah. I thought I had doubled it in. Write the equation that contains this vertex and that point. Poor favor.
Wait, we're writing it in what form?
What's the only form you can write it in?
Vertex?
And the reason is?
Because we have H and K.
Correct. That's it. Because you have a vertex. That's the reason why you're going to write it that way. thought we had different points, didn't we? Yeah, we had.
It's
Yeah,
really similar.
It's similar, yeah.
Okay, I was gonna say.
Oh yeah, you get the same answer. don't
Yeah.
you? You got one for A?
Yeah.
Okay. And there's your answer. How could you check to see if you're correct?
Plug in another point.
No, not even that.
Oh, I did it wrong, but I still got that answer.
Go to your y equals table. So if you go, unless, I didn't screw it up, did I? We got A as 1, right? Okay. So if you go to your y equals, and you put in the, let's see, we had quantity x minus 2 squared minus 1. If I go right to my table, what point should be in there? Is it there?
Yeah.
You have a problem?
Yeah. It's there. I can see it.
Is that better?
No, I can't see it anymore. Is it there? Yeah, it's there.
Could you just substitute your answer back in for A and see if they equal each other?
That works too. There's a couple things to do. Didn't work?
I
No.
think you should highlight it. I don't know if I can see
No, I was trying to do the extra zoom. It's not working. Oh well. Zero form.
it. That would have been funny.
If we work with it in terms of intercepts, if you have intercepts, that means you're going to use the P and Q. All right? That's intercept form, where P and Q are your x-intercepts. It's the zeros of, it's a factored form of your standard form. It's just it factored out. So if you know your zeros, those are going to be your P and Q. And then obviously, again, you need to have some other point on the curve. That way you're going to be able to tell, well, we know where the axis of symmetry will be with P's and Q's. That's easy, but we don't know if it's going to be above or below, what direction it's going until you decipher what your value of A is going to be. Now, in this case here, we have our two zeros, and they gave us a secondary point, and you can graph it, and then you're going to know that your A value is going to be what? Is it going to be positive or negative? It's going to be negative here because it's down like a frown. So by looking at it graphically sometimes, you're going to, if they give you a graph or an ordered pair, if you just kind of get the rough idea of where that point is in space, if you don't get an A value that's negative, you know you've done goofed. Go back and check it. Does that make sense? It's just those, it's that little idea here. It's a little bit, sometimes it's a little bit more difficult with the vertex form because you can have a vertex and still have that point floating, but you're not going to know where it's going to go. But knowing definitely where zeros are going to be, if the point they give you, it could be above or below. Actually, you know what? That wouldn't really work. Because if you had a point down below it, it could just be on the tail end of it. Disregard that. If they give you just the graph, then you'll know definitely. If they give you just the point here, you're not going to know for certain. So, graph, good. My brain wasn't right. You got 4 of the 5 values, substitute in. Our ordered pair is the -1 and 2, so 2 has to equal A. -1. Now, if my zeros are at -2 and 3, that means it's going to be minus a -2, which is plus 2. And then the other one's going to be -1 minus 3. I know that this math part here is always relatively simple, but I don't know how many times I see people screwing it up. Here's what I would do. Take the screw up out of the equation. And just go and type this in directly. Parentheses, -1 plus 2, close, open, -1 minus 3. And do that, guys. You're going to be less likely to screw up. -4. So 2 is -4A. What's A? So A would be negative 1/2, which means your equation would have been y equals negative 1/2 x plus 2, x minus 3. You're done.
This is so much easier than those work problems we were doing on Friday.
But now, word problems shouldn't be that difficult because it's just calculator work. Once you start to understand what the graphs, what those things do, it's just straight calculator work. It really is. Hey, speaking of calculator work, oh, do you want to do another one of those, or we're okay? We'll do one more.
No.
Why are they so small?
When I build the lessons, when I do that little snapshot of the textbook sometimes, if I don't resize it right away, it just stays in smaller size, that's all. It's just the settings in the computer. Same idea, you've got 2x intercepts and a point. Write out the equation. Take a couple minutes and go. Point is 8. What is that? 2/3? So you get 2/3 for your A value, and then go go right back to write it out. So it'd be y equals 2/3 x minus 2, x plus 2. And you can do the exact same thing to check your answer. Go in the y equals portion of the calculator and just verify that that point landed there. Okay.
Wait.
What?
I got 1/10, negative 1/10.
Ah, I mixed up the x intercept.
Would the point be messed up?
The point was negative 4 and 8, so 8 has to equal a negative 4 minus 2, and then negative 4 plus 2. Because these are your 2 zeros, so your p and q. So your terms would have been x minus 2 and x plus 2. That's how you get those, and that's how you substitute it. Because that's negative 6 times negative 2, which is 12. We okay? Alright. Speaking of calculators, then, what happens if you have 3 points?
You cracked.
No, you're not going to cry. You're going to find out it's pretty easy. What we're going to do is, you guys remember how we created the 3x3 matrix before for solving systems of equations with 3 variables?
Oh, yeah.
Not really? No. We'll remind ourselves real fast here. When we have a standard form, you're going to be given 3 points. And what we're going to do is we're going to create this 3x3 matrix to solve it. So what I want you guys to think about here is remembering that this is some x value, this is some y value. There are 3 of them. What we're going to do is we're going to figure out what the a values, we're going to write it out like this. I'm going to put y on the other side. Because in this value here, we basically know an x and a y value for 3 separate equations. What we're going to be able to do is use a matrix to solve for a, b, and c simultaneously. But the trick is to be able to write out the equations in terms of x's and y's. So what you're going to do is take your value of x, so it's going to be a negative 1 squared plus b times negative 1 plus c equals 5. You okay with that? And I do that again for the next one. 0 squared A, so it's A, 0 squared is B times 0 plus C is 3. And usually, after I show you guys this once, you won't have to write out this initial step. Because now we can simplify what we just did with all those squared terms, and we can create 3 equations and 3 variables rather quickly. What's negative 1 squared? 1. So this means that I have 1a minus 1b plus 1c is 5. You okay with that? I put a 1 for the front of the c because there isn't a coefficient, just leaving it as 1. I do the same thing for the next one. 0a plus 0b plus 1c has to equal 3. 9a plus 3b plus 1c has to equal 9. Now we can create a coefficient matrix, a 3 by 3 coefficient matrix. What we did here is we took the x and y values and we just substituted in all of those, and all of our y values went there. We're going to solve for A, B, and C by just pressing buttons. Okay? Do you remember how to create the matrix? Alpha zoom. And we're going to make it 3 by 3. And what we're going to do is we're going to put all of our coefficients in. So I have a 1. Remember, always hit to the right button.
Wait, how do you, I clicked off the Zoom, how do you like move it to a 3 by 3?
Arrows, up and down arrows, and just hit enter.
Oh, what the, now it's weird.
Make sure when you use a negative symbol, guys, you use the negative button, not the minus sign. You will get, it'll screw up. And just keep hitting to the right. To go to the next line, just hit to the right, it drops down. So it's 0, 0, and then 1. And then the last row is 9, 3, and 1. Now, the reason that you see 1s all in that last column is because we don't have anything here for C. We know all of our C values in our equations all have coefficients of 1. Because in standard form, there's no x value here. Okay? There's no x value. Now, in order to make this work, we have to hit the x and the negative 1 button now. What we're going to do is the calculator is going to do the inverse of the coefficient matrix, and we have to multiply that to the solution matrix. Times, we got to create another matrix, alpha zoom. We want 1 column with the 3 rows.
Wait, do you need to do, will you just square the matrix?
No, it's x to the negative 1. It's the x to the negative 1 button here, right below math. That's the inverse
And
button.
then you click times?
Yeah, so we're multiplying. You don't really have to hit times, but I'm just showing you what you do. And we're creating a 3 by 1. Eventually. And now in this column, I put my answers. Yes, sir?
Wait, why do we put the negative 1?
It's the inverse. What the calculator does is it finds the inverse of that matrix, and when you multiply an inverse matrix times something, it's going to solve for all your variables. It's a matrix operation. I can show you the long form of it, but that big piece of paper on the back wall, you've got to do a lot of that. You don't want to do a lot of that. That's why we have an inverse button. What do those stand for then? A, B, and C. Okay. What you're doing there is we just solve for A, B, and C by using a matrix, by using the calculator. The calculator, when you work with matrices, makes your life so much easier. So here's your A, here's B, and here's C. So it would be y equals 1x squared minus 1x plus 3. And there's your equation.
Wow.
No, you don't have to have that. It's okay. You don't even have to have the 1 at the as long as you minus x, you're okay. So what an inverse matrices do is they're finding the inverse of it, and then when you multiply the inverse to a solution set, it's figuring out what do I have to multiply all these together by to make that solution out. That's what it's doing. So it's just doing a bunch of calculations for you. Finding the inverse of a 3x3 matrix takes forever, and then you'd have to multiply that out and get determinants, and it's just a pain. You could solve a system of equations rather quickly by just, obviously in this case, we know that C is 3, because we had 0, 0, 1. So we knew that C had to equal 3. So you could have just done substitution and done the two-system equation. But once you get the hang of putting things in the calculator, it's really fast. Okay, it is really fast. The mistake that you're going to make is when you have something that's negative, make sure you square it with parentheses around it. That's really where you're going to mess up. Okay? Let's try another one of those. Same basic idea. So what we're going to do, I know that my first value here is going to be -2 squared. What's -2 squared? 4. The next one's going to be -2. The next one is just C.
How do you know C?
Because there's no x value here. C's for all of these, all going to be 1. Okay. I know I'm going to put that to an inverse, and I know it's going to have to be multiplied, and it has to equal -1. Same thing here. It's 1 squared plus 1, and it has to equal 2 squared plus 2, 1 has to equal 27. See how much faster it's going to be once you start understanding where things are going. It is quite literally. Would it be cool if these things made noise? Yes, sure. I probably get irritated with it like in 30 seconds. Maybe 20. That's basically what we're looking at today. I'm not going to get too much. Well, there's other parts of this section. We'll worry about that more tomorrow. I wrote down which ones tonight. All right, so let's see. We'll do the regression stuff tomorrow. So in section 5.8, what I'd like you to do, I have 3 of each of these styles. Nah, we'll change that. So it's section 5.8.
Out of bounds.
There's 3 of each style we talked about today. Please make sure you remember your calculators again tomorrow for definite. What we're going to do is something called regression. I'm going to show you guys how you can take a table set of values and have the calculator formulate an equation for you. We use it's called regression formulas. We actually can do that in a whole bunch of different formats. We'll do quadratics every tomorrow. Oakley,
Do, 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 do.
I typed it on fast.